Hello everybody. What you're looking at here is a pair of Hico model 232 vacuum tube voltmeters. You know, some time back I had to have one because, believe it or not, with all the other things that I've acquired, I didn't have one. So I found this one on Etsy, I think it was, for about 30 bucks a couple years back. I bought it. If you take a look at it, it's not in bad shape. I mean, I'll put this on here. It's just an adapter. But it's got the meters really faded. You can see that's the just the static from my finger on the glass. But it works well. It was really badly. It needed just some care. It needed gone over, and there's not a lot to it. It was just a couple of power supply capacitors. The electrolytics I updated. Took out a selenium rectifier, and that was about it. There's not a lot in it, like I said, that really needs updated. But anyhow, I happened to see this one. As you can see, it's not faded on Craigslist a while back, and I had a buddy pick it up for me, my friend Chris. So I want to take a look at this one and see. And originally I thought maybe I'll just swap the meters, but then I see this has a little bit of a crack in the meter face right here, so I'd have to swap out the plastic as well. But I'm going to open it up and see real quick, and if need be we can open this one again and I'll show you what we did. But there's not really much to open these things up. They have two screws. Pull this little zip tie off here. Yeah, just two flat blade screws. That was pretty much standard on all these Eicos, I think. They were big on using flat bladed stuff back then. That's that and that. And then it just merely pulls right out. So, one thing I noticed already that I kind of like, doesn't look like the battery got too bad. This one, where the battery was, it leaked acid and it went everywhere. This looks like it might have had some leak and someone cleaned it up mainly. Put the inside of the case. There's the inside of the case. Put that down at the side here. Now there's two vacuum tubes here, and I'll go ahead and check those. There's the area where the battery might have leaked a little bit. I can see some discoloration. I haven't plugged it in, obviously I haven't done anything with it. Our supply cap got to go. Well, actually, there's a few more than I thought. There's 1, 2, 3, 4, 5, and then the rectifier, and then usually, well, I'll end up needing a resistor too, because these have a higher voltage drop than a solid state one, so you have to make it up. But it's real simple. It's only a couple volts difference, but I like to put them back to about where they should be. And when we change that, I'll show you how you can check that right off the bat. I put a little decade box in there and went through until I got the resistance that the schematic said I should have, and that was the resistor I chose. But even if I wouldn't have put a resistor, the difference was only maybe 15, 16 volts. It wasn't really that much. But I should have all these parts, because when I did this one, unless I stuck them in a different radio or something somewhere. But I think that's what I'll do, is I'll dig up the parts and maybe update this one as well, and then decide what I want to do with the meter, or which one I want to keep, or keep them both. Anyhow, I just thought you might want to see what happens when you open these up. the insides of them, and to do the alignment on them. That's what that's for right here. These, as you can see, you can get to them right from externally. And it's pretty easy to set up. But these things were, as everything was back in the day, they were a little more, required a little more maintenance. You don't see easily accessible things like this on today's digital voltmeters, but they generally hold their adjustment. All right, well, as I get some parts for this, we'll move on. So this one here, and can't remember if it was me or not that did this, but something I usually do is a lot of times if the straight screws that come with these are at all torn up and I have to replace them, I'll replace them with Phillips. But this one here, when I see this, it has a hole right there. Somebody had drilled a hole right there. So when I see this and how faded the front of it is, I almost think that maybe somebody mounted this to a wall or something, almost as a display piece, maybe outside where the sun beat on it and bleached everything out. I don't know really why else this hole would be back here. So just a thought, but I'm going to open it up real quick and I'll show you what the inside here of this one looks like. So pull these two screws out, same as the other one. And same thing. And if you've seen some of my videos, I've used this one. Here's the inside of this one. Not quite as clean. It's got that and the hole drilled there. So if I was really worried about a pristine piece of equipment, I'll obviously go with the other one. Here's where I showed you, or I told you, the other battery had eaten away at that. So I took it and I still wove it, and then I used like a almost like a silicone oil and just tried to control most of that. But it actually ended up, I had to replace the tube socket right there because it rotted that all away. Put the tube socket in. Here's all the new capacitors in it. Here's the electrolytics down below. Get it so you can see in there, but with the light. But anyhow, you can see that again, really not a lot to it. So here, put this one like this, and then this one like this, and you take a look. Take a look and see. So I'll clean this frame up a little bit and see where I end up with as far as that goes. So there it is. Looking to see if I see any major differences. These were, as you know, these were both kits. Hico or kit rate or kit builds back then. I see one difference right here is this wire that runs into here. Here they have not that it really matters much, but they have, looks like one of those sheeted black, and here they just have a red wire. So I'll look it over and see if I find any big differences that I can show you. Oh, I'll show you here. So here's where I took out the selenium rectifier and put in, I can't even see, was that a 1000, 1N4000, yeah. I'll cheat, put the magnifiers on it. Yeah, it is a 1007 or 4007. Yep. Happened to have a ton of those. And then there's the resistor that I had to use to drop the voltage down back to where it was supposed to be. But again, as you can see, I just took the selenium on and put a little terminal board in there, and that was it. So we'll see. We'll see where we end up. So, something about capacitors. And if you look at the older capacitors here, they say outside foil. They all say that. Somehow they're marked outside foil. And I would imagine in the way that they're made, that outside foil is the part that's closest to the exterior of the capacitor, obviously. So they're showing you which lead would connect to the outside foil side, the most exterior part of the capacitor. And that part should be the lowest, the point closest to ground, basically. So I watched Mr. Carlson's lab. Very, very bright fellow. And he made a tester to see which side was the foil end, because when you get the new capacitors, as you can see here, they're not marked with an outside foil end. Don't mind these leads, this is just something I was trying. They're not marked with an outside foil end. So he does have a tester that you could build, and I just haven't gotten around to building it yet. But one thing I was wondering was, if there really is an outside foil end, then basically you should be able to detect that. And I think that's what his tester pretty much does. So I was just curious if I put maybe a 500 kilohertz signal through this, and then you'll notice there's a little dot there, because I think with my testing that's what I came up with. But I put a signal through this, and then I just laid the scope lead on the exterior of this, and I put it with the positive on both this side and this side to see what I got. And it appears when I put the positive on this side and then the negative on this side, I can actually sense a signal, but when I switch it around the other way, I can't sense a signal. So I'll show you what I found on the scopes. We have the capacitor. As you can see, my little black lead that's telling me that's probably not the foil, or that probably is the foil side. I'm going to connect that to ground and see what happens. So when I put a little bit of a signal through this with my signal generator, and I just run my scope lead, you can see it, trying to get that in the picture. There's really no discernible difference. Now just to show you, if I put the scope lead there, that's off the screen, and if I put it on that side, you wouldn't expect to see anything. That's the ground. That would actually take away all the noise. So I'm going to switch it around the other way, and I'll put the positive on the little black dot side, and the negative on the opposite side, along with the scope lead. And now I'll take the scope lead, and when I put it just across the outside, I'm losing everything. When I put it just across the outside, you can see I'm actually seeing something that time. I'm actually picking up a signal. And again, if I touch that, that goes way over, and that would be ground. So it would lead me to think that the way it's connected now puts the positive of the signal closest to the shell of the capacitor. So this lead would be the foil side. So thinking of that, something else I wanted to try was, as I showed you before, just me touching that sends a crazy signal. I'm going to set this down to probably as low as it goes. I'm going to put this onto the lead, were to ground the other side of the lead. And there I'm holding it, and I don't see anything whatsoever. I'm going to switch the leads around. Aha! That's the way I would expect to have got something. Now let's switch it the other way and see. Is it just an anomaly or what? So I'm still working on my mystery of finding out which is the coil, or which is the foil side, this side or this side. And these capacitors came from a different vendor. And my theory seemed to be working okay, and as you can tell I put a little dot on that. I believe I showed that already. So now this one seems to be exactly the same no matter what. So what I wanted to do was just put a lead, a scope lead on one end, and then put a signal. Now one end of the scope lead is going to the ground of the signal generator, and I wanted to put a signal and see if it's bleeding through. Theoretically, I figured the foil end would have a better signal on the scope. So I'll show you the thing that shot that theory all to heck, if I can do this without. I'm going to have to zoom out. Okay, there's the scope. I know it's at a weird angle. I'm going to try and be able to show you the scope and the cap at the same time. So there's the cap, and I'm just going to take, you can watch when I move that close, and put a signal on there. You would think that the foil end would have a better signal. That's about, oh, according to the scope, somewhere in the area 50 to 70 millivolts RMS. So, okay, I'll show you that. So now when I switch it around and put the scope lead on the other side, same thing. About 70 millivolts RMS. Scope lead's a little closer. My hands. I would think that this side would be your foil side. That's just a guess, but it's so close and reading that I don't know if it is or not. So what we're going to do is I'm going to mark that, because that seemed to be the side I got the higher reading at, so I'm going to mark it. Now with the other capacitors, I almost got no reading on one side and a small reading on the other side, whereas this one I get about the same on both sides. Right here. So now of course I put a little dot. I'm going to take it apart. But when I start to tear the paper off, we're going to lose that dot. So what I'm going to do is cut this lead real short. And then we'll know one with the short lead is also the dot side. So I cut it right about, about half of what it should be, so there'll be no mistake in it. Okay. So now I'm going to peel this paper off if I can. Just start to unwind it. Now it's turning clear. I can definitely see some kind of silver in there. Okay, and so winding it and unwinding it rather, and unwinding it, the other end fell off of the capacitor. I don't know if you can see that in there. I'm trying to let it focus. But in the very center, there's a hole on the side. And that was the side that succumbed to my tortures last. That would be the inside. So that was the one that we didn't cut. So the testing did show the outside was the one that was cut, and that was the first one that fell off. So apparently that's a valid test. One of the other things was, when I looked at some of these and kind of tested them the same way that Mr. Carlson did. And of course, when I was doing it, I was looking on the positive end and seeing which had the highest signal. Sorry. He was looking on the negative end and see which had the lowest signal. So it worked out either way. The dot goes in the same location either way. The dot indicates which lead is closest to the outside, or the outside foil. So that being said, we're ready to start, and I'll put this one away, and we'll do this one here. And yeah, you can't really see it yet. Let me zoom up a little bit. It's a little bit below your view. There we go. Yeah, I'll put this one away, and then this one here is the one that needs the capacitors. I'll do the capacitors, and if there's anything interesting to show you, I will. But then before I do the selenium rectifier on the top, we'll video that and what my procedure was to calculate what resistance I would need in there. But let me clean up the bench a little bit and get to work, and I'll be back. Okay, I have all the capacitors done and the diodes in. I just haven't started it up yet and decided what I needed as far as controlling the voltage after the diode. But one thing I did want to point out, in case you're doing something like this, and it's not only on these, but I see them on a lot of things. But this is the power supply section right here. This guy right up in here. And if you look, and I'm going to zoom in and show you something you might find a little bit interesting. Okay. Right here is the selenium rectifier or diode now. But what's interesting, that's the cathode, but yet they have a positive symbol there. And when you look at this, you're also going to see that the diode itself, I'm trying to get this in so it doesn't lose too much focus. I can show you again if I can't get it to focus because of the screen. Well, anyhow, I'll show you when I have it laying on the table. This is the selenium rectifier. I'm going to put it down here. I'll show you later. It has a little plus mark on it too, which indicates the cathode. So it's just something to be aware of. So as you'll see, I have a substitution resistor box, and it's plugged in to the right after the diode, before the diode would go back into the circuit. So it would be actually right after the cathode. So the cathode's not attached to anything yet except through this substitution box. And up in the schematic it showed that we wanted 50 volts. So I started with 1,000 ohms, 1 k ohm, and that's a good place to start, I think. And it's not, there's not a lot of current here, so you're not going to be dealing with a lot of power, so it's not like you're going to worry about melting your substitution box if you have a little junky one like this. But anyway, I started 1,000. It's been on and running for about 10 minutes, and I'll show you what I have here as far as voltage goes. Let's see. I'll pull the meter over this, or the camera over this way, so we'll get a little bit better screenshot. That's what, 47.3. So what I'll do is I'm going to drop down and maybe a 680 ohm resistor. 48.6. 49.4, that's at 470, so at 330. 330 is probably going to be our key. I just want to check when I adjust things on the front of this meter to see what kind of readings I get. Because I'm assuming that I want that to be the highest it's going to make it is 50. So let me see. Nothing there changed anything. The potentiometer for the meter is really tight. I'm going to have to lubricate that. Nothing's changing anything. So what I'll do is, I don't know if you have one of these Eico boxes, but they're not the most precision devices in the world. So what I'll do is I'll take it off there and I'll check and see what the resistance reading really is. And if it's 330 or somewhere thereabouts, that's the resistor I'll throw in. And then we'll start it up again and let it run and see. Right now it's going between 49.9 and 50.1, which can't get much better than that, but we'll see what really happens if I can find a good resistor for that. So the ohmmeter is saying 300, stop it. The ohmmeter is saying 334 ohms. So that's pretty close. So let me grab one of those and put it in and see what we get. Alrighty, let's see. As promised, there's where the selenium rectifier came out of. I put a little stand in there. And then there's where the diode comes up and goes through the little bit of a resistor to give it a little bit more reduction. Like as I said, I'm not sure what the voltage drop across the selenium rectifier is, but you know, across a solid state like this, it's only about 0.7, so you have to make up for it a little bit. And as you saw, it really wasn't that much. So I'll show you where we're at now. It's been on for about 5 minutes, 4 or 5 minutes. It's at 50.5. That's pretty good with the 330. I think it ended up being 322 or something, so that was pretty close. Also, I know I promised I would show you the this is the selenium that came out of it, and these are pretty common. I've seen quite a few of these. If you look up the Model 50, and you'll notice it has a little plus, and that correlates to the plus that's on the schematic. But again, like I said, when you were replacing it, forget about looking at that plus sign. Put it in the way the schematic tells you, and you'll be good to go. So I also, while I had this, let's see if I can do it without blowing anything up, I replaced the front lens. I swapped it off the other one, so now I have one that you can actually see the red numbers on. There we go. Come on, focus there. There we go. I also lubricated these up. They were super tight, and just a little bit of contact cleaner in the back, and then I take the knobs up and put a little drop down and let it go down the shaft. So that was it. So I want to finish buttoning up here, and then we'll calibrate it, and then as a special treat, when we're done, also this came with the probes, the Eico probe. So it looks like it's definitely shown its age. I'm going to replace the coax on it, and we'll put that back into service, make sure that that works as well. But coming along quite nicely. And I almost forgot. Here it is with all the caps in there. You can see 1, 2, 3, 4, 5 caps replaced, and the electrolytic down below there. There you go. Yeah, all in all, the inside's in very nice condition. It'll need cleaned up a little bit, and after I get it all up and running, we'll do some cleaning on it. Okay, that is the reading on the probe when it, oh, my hand just slipped, when it's in the DC mode where it should have the resistor in series with it. So what are we getting? Oh, let me see. Just drop the leads. I didn't take it apart yet. I'll show you the probe here in a minute as soon as I quit throwing things on the ground. So 1.3, it's kind of all over the place. I'm going to take a look at it and see why. But let me zoom you over so you can see the probe. So here is the Eico Uni-probe. It has that same, let me zoom out a little bit here. It has that same connector on the end of it. And here it is here in Oliver. In order to, would you get out of the way? In order to switch from AC to DC, you can see it's right there. There's a little detent with that little red knobby, and turn it the other way. On this side it says AC in ohms, so that would be the side without the resistance. So here's the cable, and I don't know, it might not be that bad. It just, to me, it feels like a little, just a little brittle. Like, and you can see here, it's got some stress cracks. And here's actually the negative lead that goes with it. Yeah, I pulled it out of the view. Here's the negative lead that goes with it, and get out of the way, dog. I'll just put a new cable on that as well. But it has the original banana jack and alligator clip. So we'll do that, and then when we're done, once I open this up, I guess I should read the instructions. That tells you everything, the manual that came with it, because this was a kit. It tells you how to build this. So we'll take a look at that to get it apart and see why that resistance is bouncing all over the place. Okay, so let's see what happens when you remove the set screw. It's a plastic screw, so I'm trying to be very, very careful with it. There's that. And oops, if you're still following along here, let's see if I didn't lose you completely. Okay. So there's the mechanics of how that keeps the contact there. That would probably also explain why I wasn't showing a very good contact. You can imagine over the years that this friction contact there, just copper probably loses its conductivity, or just gets some corrosion on it. And if you sprayed some contact cleaner, it'd probably be okay. So I took another set screw. I'd imagine that's for the cable. And then this should slide down like that. And I'm imagining that the resistor is in here somewhere. It's underneath that. So let's check what I have as far as resistance goes on the resistor itself. Probably going to replace it just because I'm in here, but I'll put that on there and there. And I'm showing 1 meg, 1.067 meg, 68 meg. So trying to get the zoom over to show you the meter. So yeah, I'll find something that's closer to just the standard 1 meg and we'll go from there. And all in all, this looks in pretty good shape. I'll make sure I don't lose my 2 little set screws. Okay, for the Eico, what I'm going to do is replace the cord on this Uni-probe that they have. And I looked at a bunch of different cords that I had laying around, or coaxes, and even went and ordered some, but I have here some RG58AU, and it's multi-strand center conductor, and it's very flexible. I think every bit as flexible as this, maybe a little more. So I'm going to actually replace it with that, and I have a new 1 meg ohm resistor, and we'll tune back in. I don't think I'm going to find anything in particular about them, but as we continue, I'll come back. One thing I did want to add, got the probe done. It went pretty easily. The 5/8's just a little bit thicker than the cable that's in there, so you have to work to get it through the back piece, but you'll be able to do it. The other thing is, if you've never changed one of these, the old microphone style plugs, or that Eico always uses on their test equipment, what you do is you take this screw out, and then you'll see this spring here is part of the ground too, but that's where the shield connects to. And then this is where you heat up, and you actually heat the center of that. Move my finger out of the way, and theoretically it should pull right out of there. I don't know how much work. There we go. Pulls right out. So then you unsolder the shield from the spring, put it back in there, solder it, kind of measure it back up, and you'll be able to pull that right through. Use your solder sucker to pull the center solder out of that, so you can see what's happening as you slide the conductor right up there. And then after you've done that, soldered in, cut it flush, and you're good to go. In case you didn't see, I know I have the electric solder sucker, but every now and then if I'm just doing something small like this connector, I'll use this. And as you can see, it pulls it right out. So don't be afraid to get this tip into the work and get it nice and get your work flowing, the solder nice and hot. This tip won't melt like you'd think it would. Get that in there, put it right up against that, and yeah, go like that, and that produces a nice amount of solder, or I mean suction. It'll pull the solder right out of there. So that's a good thing. This here, the spring, that's going to take a little bit of work. The spring's going to take a little bit of work, as you can see. It's all the way around, but really not that much work. But I'm not going to do it on camera. It'll just be kind of boring. So the technique that's working for me, to show you a little bit on this, is I just take my soldering iron and I keep brushing it that way, and you'll remove the shield. Once it heats up. It didn't take you out of focus, yeah. You can't see through my hand. I'll try that. It takes a couple seconds to heat up. Come on. There's a lot of area here. Yeah, you see once it heats up, you know, I just keep brushing it forward. You'll eventually get all the shield brushed forward. You can see right here is a big piece there. And then you can tap it every now and then. It'll take some of the loose solder off. I was using the solder sucker too. Here we go. That's off now. So that's off. So let it cool down before you try and stick your new piece of plastic. Let it cool down before you try and stick your new piece of plastic in there. And it should solder right back together. I have a piece of steel wool here I'll use. some steel wool to clean it up. Just to get the old, you can imagine there's a little corrosion on there, and even the solder flicks around. So anyhow, that's a bit the easiest way I find is just take your soldering iron, let it heat up for 10-20 seconds. Once it heats up, start brushing it forward, and you'll start standing up the conductors right there, the shield right there. Where's it at? Where's it at? There it is. You'll start there's the shield right there, and then you'll see it looks like all the edges stood up. So when you put the new one in, you stick it through the spring, and then you bend these back down over the spring, then you solder it. Alright, and there it is, the finished contraption. Just like any time you solder coax, watch your heat, make your solder joints nice and thin, but make sure you get good coverage, because there's a lot of plastic and rubber to melt with coax. So, and of course you want to check it at the end. So I'll just check with the continuity tester. Let's make some noise here. There's that. I'll check here, and nothing there. Nothing there, but when I do at the tip, I should get something. And there we go, nothing on the ground. And that's on the AC ohms. So if I put on the DC with the 1 meg resistor, I wonder what it gets. Nothing. Let's put it and see. I'll put it on the 1 meg scale, and I get 1.007 ohms, meg ohms. So, okay, so that's all good. The next thing we're going to do is move on and do the calibration, and then we're done with it. Oh, I did order some wire to do the negative lead too. I didn't have. They were using 16 gauge meter wire, and all I had was 18. So I figured I'd get somebody to make some test leads. Be happy with that. And again, I don't usually use these as precision, trying to find a point. I'm looking for maybe 200 volts DC or 110 volts AC, not the decimal point. So they look pretty good. So as you can see, this is done. I got the front all cleaned up again. Meter's pretty cleaned up. So I'll finish the negative lead, which I just got the wire for today, and it'll be all done. It'll be on a bench ready to go. And then I think I have another Heath kit we can look at. So, all right, well, thanks for watching. I hope it was helpful, or I hope it's something you guys might want to try or play around with. As you see, there's really nothing to it. If I can do it, you can do it. Thanks for watching.